So here's another example where we're multiplying two different functions, so we have to use the product rule, and inside of the product rule we're going to have to use the chain rule. Okay, so we're going to use the product rule. So remember, the first thing is anytime we have roots, we're going to write it as fractional exponents. So instead of square root of z, it's going to be z to the 1/2 e to the minus z. Okay, and let me color these in again to make sure we're on the same page. Okay, so we get the derivative of the first using the power rule, so we're going to have 1/2 z to the minus 1/2 times the second, leaving it alone, so e to the minus z plus, now the first one we leave it alone, so z to the 1/2 times the derivative of the second. Now when we get the derivative of the second, we have to use the chain rule. So remember, the outside function is the exponential, so we have e as the exponential, leaving the inside alone, times the derivative of the inside, which is here in black. The derivative of negative z is just -1. And that's it. Okay, let's try this other one. So we have f of x is the cube root of 2 to the x plus 5. Okay, so again, whenever we're getting derivatives and we have roots, we turn them into fractional exponents. So instead of cube root, we're going to have 2x plus 5 raised to the 1/3. Okay, now in this case, the outside function is this guy that's being raised to the 1/3. And the inside is the 2 to the x plus 5. Okay, so we're going to apply the chain rule here. So we're going to have first the derivative of the outside here in red, so we have to use the power rule. So we're going to bring the 1/3 down, leave the inside alone, and subtract 1. Well, 1/3 minus 1 is -2/3. And then times the derivative of the inside. So the derivative of the inside, the derivative of 2 to the x, remember, is just itself, times natural log of 2, plus the derivative of 5 is just 0, so we leave that one alone. And that's it. Okay, so to get the derivative of this guy, it looks like what we want to do is use the quotient rule here for this part, but really, since you have a constant on the numerator, there's an easier way. You can just bring the denominator up, and remember, when you bring this guy up, you have to change the sign on the exponent. So these are equivalent, and we leave this one alone. And now we can find the derivative just by using the chain rule on this first part, and this one just the power rule. So let me label these guys. So we have, let's say, the outside function here is going to be the natural exponential, and then the inside function is going to be the -3x. Okay, so then the derivative of this guy is the derivative of the outside, so the derivative of the exponential is just itself, leaving the inside alone, times the derivative of the inside. So the derivative of the inside is just -3, and then plus the derivative of x squared, which is just 2x. And that's it, you're done. Okay, so here we have the outside function is going to be this guy being raised to the 4th, and the inside is this quotient, and so we have to use the quotient rule. Okay, so one thing to note is that here A and B are constants. So you treat them as constants, like if they're 1 or 2 or whatever. Okay, so then the derivative of this guy, so we get, remember, the derivative of, hold on, let me mark this. Okay, the derivative of the outside, so this would be, you bring the exponent down and subtract 1 while leaving the inside alone. Times the derivative of the inside. Okay, so the derivative of the inside, if we use the quotient rule, we're going to have the denominator squared, and then remember you get the derivative of the top, so the derivative of a constant is just 0. 0 times the bottom, you leave it alone. Obviously this is just going to equal 0, but we'll write it out anyways. Minus the top times the derivative of the bottom. Well, if a is constant, the derivative of a is 0, and the derivative of z squared is just 2z. And you can simplify this a little bit and multiply this, the 0, so this guy is going to equal 0. But I'll just leave it like that. Alright, I'll do it. Okay, so let's simplify it one more step. I'll leave this guy alone. B over a plus z squared to the 3rd. And then this is negative 2bz over a plus z squared. Squared down here as well. And that's it.